Hello everyone, we have written this code in Python to predict numbers from their images. And for that, what we are doing is we have this database. This is an open source database, anybody can use it. This is Modified National Institute of Standards and Technology database. It's a large database of handwritten digits. So we load this database and and it has a sample of some 60,000 handwritten numbers. And the size of every image would be 28 by 28. And then we have another set of test which would be 10,000. So we will train our network on the set of the 60,000 images which are numbers, and then we will test it on this database. And we will use random numbers from this database. We will give random positions. We will see if our network is able to predict the numbers based on the learning it has gathered from this set. All right, so let's start. And we are using Google Colab because Google Colabs provides you the GPU which is needed for similar exercises. Otherwise they will take a lot of time, so you can go here and make sure that it is running on GPU. So we have loaded all the libraries. Now we will load the data. And we'll run these commands to make some changes to, kind of clean the data so that it's ready to be tested. And this is our main network. These are all the layers in our network, and this is the link. It is not exactly similar network. The one we are using here is different, but it is kind of follows this, that we have an image, we'll take a section of the image, we'll create a feature map, and then we'll take another, again we'll do subpooling, which would be like half shortening the image size, and again doing the same step, again doing subsampling, which we call pooling. And then later on once this two-dimensional data, we'll vectorize it, we'll convert into one-dimensional. Later in the network, that 1D array of data, which is a vectorized form of data, will use softmax to predict the probability, which that once we get a stream of data from this network, will predict which value it represents the more, which number it represents the most. So these are the these are the layers which I was showing you in this image. So let me run these. Let me compile it now. We are using SGD optimizer here. And now we are running only 3 iterations. Normally people run a lot of iterations, sometimes more than 50, but we are running 3 iterations here to test it and rectify from the error, and get it increase its accuracy with every bit. So you will see it is, again, this is the set which has 60,000 images. Every image has an equivalent actual digital value. Like if you have an image of 505, you will, on the similar position, you will find 5. So it will test and it will see how accurate it is, and then it will validate against this test that based on this iteration number 1, my accuracy is this much. Let me test it against this database, this set, and let me see what accuracy I'm getting. So this is a smaller set because this is 10,000 records, so your accuracy would be more here comparatively. So let me run these 3 iterations and you will see. Okay, so see, it is running these records after 60,000. This is the first iteration, epoch is iteration. You can see the accuracy is increasing here, 89% accuracy, 90% accuracy. And now against the 90% accuracy, when it goes against the smaller set, it gets 95%. Validation accuracy is 94. Now let's see how much 90% accuracy on that 60,000 records increases. So 90% becomes 94 and 94% accuracy becomes 95. And this is the third set. So 94% become 96, and this is over. 3 iterations are over, and our final accuracy is 96%, and on the validation test at 96. More and more iterations we will do, and this accuracy will increase close to 99%. So I think 3 would be more than enough. Now we will pick out of those 60,000 records, we will pick any random number. So let me pick an image which is at position 37, and we will see that image. So at the position 37 we have 1. Now let's see if we are able to predict that number digitally, if our network is able to predict. So number predicted for position 37 is 1, so it is able to predict that number, that this is 1. Let's change this value, make it 39. Oh, on 39 also we have 1, so make it 54. We have 6, and look at the 6, we had 6. So let's see. So the position 54 is 6. Let's do 115 is 4. 115 is 4, and I can give a series of number as well, and you will see a series of numbers which would be 7 9 1 4 1 9 7. Let's see, 4 1 9 7. 35, 12, 23, 2 9 5 2 9 5. So the test is working. Thank you everyone.